We've taken a look at two of the four threads or themes that we want to weave into the historic development of information technology. So the third one is logic. George Boole was an English mathematician, also like the others that we have talked about and will talk about, sort of a Renaissance person in that he was involved in many different activities and certainly a genius when it came to issues of logic. George Boole wrote a book. Oops, where's my book? Don't look. Oh, why is the cartoon coming up first? Don't look at the cartoon yet. George Boole wrote a book in the mid-19th century, so he's living in the 1800s. In the 1850s, he wrote a book called An Investigation into the Laws of Thought. Now, you don't have to remember the title of that book, but I want to tell you what George Boole was attempting to do. What George Boole hoped to do is to figure out, how do people reason? How do they come to a conclusion? He had a pretty grand plan in mind. George Boole hoped that he could somehow settle disputes using logic. Rather than people hitting each other, or rather than people suing each other, Boole envisioned that if there was a dispute, each person could formulate what it is they wanted in a logic, and then the answer would just come out. Well, George wasn't able to do that, and Boole freely admits that it was a very grandiose idea to try to uncover or discover how people think and reason, and we're not even sure if there are any rules that might govern that. But along the way, George Boole came up with something that today we call Boolean algebra in his honor. He didn't call it that, but that's what we call it today, Boolean algebra. Now, Boolean algebra it sounds horrible, but it's actually very straightforward. Any statement in Boolean algebra can have only one of two possible answers, and I bet you can guess what they are. True, false. That's it. Every statement, every expression or equation in Boolean algebra has one of only two responses, true or false. Again, if you think about what George Boole was up to, an investigation into the laws of thought, he really hoped he could uncover how people think, reason, come to a conclusion. Yes, I want to do this, true, or I don't like that, false. Now, finally, with all that background, see, my little cartoon will make sense here. It's entitled Boole Orders Lunch, and he's looking at the menu and he points at things. Yes, no, no, yes, yeah, no, no, yeah. Yeah, it's one of the funnier. Yeah, thank you. And as you know what? 0, 1 is just the same thing as true, false, or yes, no. They're all the same thing, exactly.
Well, we have both ways.
Mm-hmm. Then we've got it. 0, 1 is computer hardware. George Boole set the mathematical foundation for computer hardware 100 years before we had computers. Today, computers process, computers work via Boolean algebra, via this logic that George Boole uncovered.
So he's the co-founder of the 0, 1?
Well, the idea of 0, 1 did predate George Boole. The binary system, I'm not sure I can tell you what the first recorded instance of somebody looking at that was, but it did predate George Boole. And Boole didn't really think in terms of 0, 1. He was always thinking in terms of true, false. But the later connection, which did happen in the 20th century, was an information technologist saying, hey, George Boole's true, false, we could express that equivalently as 0, 1s in a circuit. Okay? So there was another insight and connection that was made there. But yeah, this is all about zeros and ones. Okay? I'm sorry, this is all kind of out of order. And again, you don't have to remember the title of the book, but an investigation to laws of thought, trying to discover or uncover how people think and reason, was what Boole was originally up to. But what he did come up with, although at the time he thought was, I don't want to say failure, but he said that wasn't what I wanted, is extremely important today. Because today computers use Boolean logic to do everything that they do. Remember when we talked about and, or, not, XOR, all those gates? That's just George Boole's idea, and we call them Boolean functions. Cool, huh? So that's just another thread or theme that's woven into the fabric of information technology. This is all out of order. Yeah, hey, guess what? George Boole created Boolean algebra. He didn't call it that, but that's what we call it today in his honor. So as you saw before with the gates and the circuitry and the ones and zeros, yeah, that's all due to George Boole. All right, final theme and thread that we're going to weave through IT here is this concept of general purpose. What really sets a computer and IT apart from most other tools is this. There are many tools for solving problems. But what separates a computer and IT is that the tools that we both create, apply, and manage are general purpose. What that means is the user can decide what the tool is going to do. You do this all the time. You're working with a computer, and 1 minute you're using a word processor, and the next minute you're using a web browser, and the next minute you're using a graphics package, and then a game. Oh, we don't do that. And then keep going, keep going. Same hardware, same technology, but different purpose. It's a general purpose device. This can be traced back to the pioneering work of Charles Babbage, and we mentioned him before, in passing. And again, you'll notice it's 19th century, doing most of his work in the middle 1800s here. Here's Charles Babbage. Charles Babbage was an English mathematician, philosopher, inventor, yada, yada, yada. Interestingly, and you're going to read a little article on this too, like everybody else I mentioned, George Boole had a Christian worldview. And that somehow played into the things that he was doing here. Did I say Boole? Boole too, but Babbage specifically. So, Babbage created a couple different devices. Originally a device called the difference engine. And then, even before he was done with the difference engine, he had a better idea. And that better idea was a device that he called the analytical engine. We still use the term engine today when we talk about processing, don't we? Like search engine? Yeah.
Mechanical device.
In this case, it was a mechanical device, right. George Boole, dang, I can't get Boole on my head. Charles Babbage's device worked with steam. It didn't work with electricity. As a matter of fact, many people believe that if Charles Babbage would have had electricity available to him, he could have created a true computer fully 100 years before anybody else. Because the analytical engine basically was a computer and was actually, although Babbage could never complete it, the Royal Society and the British Museum collaborated in the very late 20th century, 1990s or thereabout, to actually use his plans, and that's what you see there is a modern reconstruction of the device, and it does actually work. I'm sure it's there in the British Museum. Yeah, I have not seen it. That'd be cool. That'd be cool. Okay, who? Charles Babbage. What? This thing, the analytical engine. Where? Did I tell you? England. This is England. When? 19th century, mid-1800s. Well, that's all interesting, isn't it? Gee, we haven't done this for a couple people, so maybe we should redo this to solidify it. Why?
Simplify.
Yeah. And even before that, he needed a tool to solve a problem, right? Babbage, like everybody else here, was being very practical. He was confronted with a problem. The problem in this case dealt with mathematical tables, specifically books of logarithms. Now, in the 19th century, if you're going to do complex arithmetic, there were some shortcuts. We didn't have calculators then, right? We didn't have computers then. So there were some shortcuts, and one was a logarithm. A logarithm is a way to multiply by just adding values rather than going through the process of multiplication. And to do this, you looked up things in a book. Well, what Babbage noted is he'd go through a long, complex arithmetic equation, discover that the answer was wrong. He double-checked all his arithmetic. That was correct. And then he discovered there were errors in the books. And Babbage said, darn. Okay.
That's why there's a saying, the more you read.
Exactly. The more you read, the crosser your eyes get, or something like that. Yeah.
Most of the laws that are made are like a group of people decide it's correct.
Well, sure.
Yeah.
Sure.
It's not hard, it's backwards. It's 75%.
Yeah. Right, exactly. And in the video, you're going to see this explicitly and why that was. But you could imagine, doing these things by hand is tedious, right? Yeah, exactly.
They
So,
always say that the people who don't believe in those laws and think differently actually achieve more. That's what it said. Like, they don't believe the traditional system.
maybe,
Physics,
maybe,
they invent things.
Yeah.
They don't believe what it really does.
maybe.
Think clearly.
Okay. Yeah, now you want to say think different.
Yeah.
Yeah, maybe so.
Steve Jobs said that.
Okay, yeah. He borrowed that from somebody. Okay. Again, could this be done manually? And we know the answer is yes. And so again, what's the advantage?
Faster
Yes. Faster and more efficient.
less number of errors.
Exactly. And on efficiency, we're focusing on errors. You know the problem. I mean, if I gave you a list of 100 numbers and I said, here, add this up, we'd all roll our eyes and say, could you do that? Yes. Okay. What are the odds, since you're really not interested in doing it, that you do it well and right? If I said, here, just add up these numbers, and I offer you no reward or punishment, but you just did it, I mean, what are the odds that you'd get it? Yeah. On the other hand, if I said, add up these numbers, if you're wrong, we'll dispatch you to Siberia, then you might pay a little more attention to it, right? But still, the probability for error is there. Exists, absolutely. Okay. I removed all the chairs to encourage more efficient meetings. The first item on the agenda is, legs so tired, meeting adjourned. I always wondered what efficiency looked like. That's why I keep sitting down up here. Yeah, we can't totally stand all the time. There's another person that I want to mention in the historic development of general purpose, and that's this individual, Lady Ada. Lady Ada Augusta Lovelace. She was if you're an English major, you may have heard of the English poet Lord Byron. Lady Ada was a co-worker with Babbage. She was a contemporary of him, and she actually worked with Babbage on his machine. Now, Babbage was a genius. The problem with geniuses is sometimes when they're trying to explain stuff, if mere mortals like us don't pick up on it in the first 3 seconds, the genius gets a little up. Come on, you know what I'm saying? No. And get all frustrated. Lady Ada was smart enough to understand what Babbage was doing. But yet she was communicative enough that she could tell other people. Because other people, what is that Babbage guy doing? And Babbage would try to explain, and he'd get frustrated. But Lady Ada was actually able to, in understandable terms, explain what was going on. So on the one hand, she was an interpreter of Babbage's works. She helped everybody, all us normal folk, understand what he was doing. And she also did something else very important. One of the things that was unique about Babbage's analytical engine was it was going to be general purpose. It wasn't created for any one specific task. In order to be general purpose, you had to change instructions. So, since this was a device that required instructions, a programmable device, Lady Ada actually was a person who created many of the instructions for the device. Exactly. And that's why today, and it finally all comes here, not only do we look at Lady Ada as an interpreter of Babbage's works, she helped the rest of us understand what he did, but many people, including me, consider her one of the world's first programmers. Programmers create instructions for computers, and although the analytical engine wasn't truly built or necessarily a computer, it absolutely did follow instructions. And she did that. And some of you may know there's actually a programming language named in her honor. There's a programming language called Ada. That's right. Good. Lots and lots of people involved here. We've seen just half a dozen. But you can imagine there are many folks. But the moral of the story, again, is not just the who, what, where, or when, but also the why. That's important. Due to recent technological advances, everything I taught you about computers is no longer valid. Now, what's interesting about that is this. It's true that technology changes very often, right? But conceptually, the concepts really haven't changed that much. The 9 grand ideas we looked at the first day, I mean, those were grand ideas in Babbage's day, and they're grand ideas now. So it's true the specific skill sets change.
Logic remains the same.
But yeah, logic hasn't changed. The logic that computers use hasn't changed for 150 years. Yeah, exactly. Okay. So, true and false, I guess. Sorry. Okay. So Cap A was the origin of information technology, that discipline where at least 4 different threads or themes were all woven together to give us IT as we know it today. Let's look at the origin of the computer. For this, we are going to start not quite 400 years ago. I'm going to start with the ENIAC. So that is 65 to 70 years ago. Yeah.
Say that.
Okay, good. Yeah.
First computer, what was it called?
Yes. Now, just so you know, different people will point to different machines as the first true computer. As a matter of fact, Brookshire says a different machine. The video we're going to see today has yet a third machine.
Sure, it was built for manufacturing the Henry bomb, right?
This was actually, I'll tell you, it was actually built for something called ballistic trajectory tables. It did actually do some things, some calculations for the hydrogen bomb. It did that later. Yes, absolutely. But the moral of the story, don't worry about what it is. I mean, if you want to know, this is the answer. Why? Because I said so, right? But anyway, there's a couple different machines that vie for the title of world's first true computer. ENIAC is an acronym. They're letters that stand for words, and you don't have to remember it. Electronic, numerical, integrator, and computer. Don't remember that. The ENIAC, I'm just going to tell you, this was the world's first true computer. It was actually built by the University of Pennsylvania under contract for the United States Army. Yes. DARPA? DARPA happens a little bit after this. Okay, yeah. But it was actually done for the Army. So let me skip ahead and tell you what's happening. ENIAC, and yeah, you notice the years, that certainly encompasses World War II, the early to mid-1940s. The 2 principal designers, J. Presper Eckert, John W. Mauchly, so Eckert, Mauchly, and that, where you see them, that's the ENIAC. By the way, and do I have other images here? Yeah.
Vacuum tube.
The vacuum tubes? Yes. Yeah, they're the 2 principal designers. Like any device, there are a lot of people involved in developing it and building it. They didn't do all the work. but Eckert and Mauchly were the two principal designers. Yeah, they'll get all the headlines. This is the ENIAC, and you can't tell, but the room that they're in here is about 50% bigger than the classroom that you're in here. This is the ENIAC, all 20 tons of it. And as was mentioned, vacuum tubes. The reason the ENIAC was so big is because it was constructed out of 18,000 vacuum tubes. And the vacuum tubes of the day are about the size of a light bulb. Big devices. Okay? Here's the ENIAC. Okay? So, let's go back. Who? Eckert and Mauchly. What? The ENIAC. When? Mid-1940s. Where? I didn't tell you. This is the University of Pennsylvania. Pennsylvania, USA. Under contract for the United States Army. Okay, yada, yada, yada. I know I'm repeating myself, but this is important to see. You won't understand the historic development unless you focus on the why questions. And yes, it's still the same answer. It's always the same answer in IT.
World's first supercomputer was ENIAC?
Well,
Processing power.
it was the world's only computer, so I guess you could call it, yeah. You could call it a supercomputer if you wanted to, because it was the only one. Yeah, yeah. It's certainly the fastest, because it's the only.
Except the world's first supercomputer.
Okay. I will not dispute that. Okay? Yeah. Speed is relative, right? Because today, the processor inside your phone is 10,000 times faster than how fast the ENIAC processed, right? Yeah. So it wouldn't seem very fast to us today. The problem that the ENIAC solved was the construction of something known as a ballistic trajectory table. I'll give you the background. You don't have to necessarily remember the entire story, but I've just tried to drive home the tool to solve a problem point. Yeah, but even for things not quite as big, if you're shooting a big gun, a howitzer, a tank, the guns off a battleship, when you shoot a large shell a number of miles, funny things happen. It's called physics. The Earth turns depending upon temperature, humidity. Yeah, funny things happen. Yeah. So to shoot it accurately, you need to compensate for that, and this is called a ballistic trajectory table. In 1943, this problem was solved using a room full of... Wait a minute. I didn't think there were computers. Yeah, there's a trick here. Here's the trick. In the 1940s and 1950s, the term computer applied to a person whose job function was to compute. The term computer wasn't used until the second half of the 1950s. Computers were called something different. I'll tell you what in a little bit. And you'll see in the video that there was a room full of women, and they were doing these things, and these are not those women, but these are ENIAC's computers, who in this case were the programmers for the ENIAC. Funny, huh? Today, yeah, and actually they were actually doing the instructions too. Yeah. Today, of course, computer means an electromechanical device, electronic device. But at that time, it meant a person. All right. ENIAC's advantages are the same advantages that we've talked about before, but here we can absolutely say it was faster. The background was Eckert and Mauchly went to the United States Army and said, "We hear you're having a problem." The problem was it took a room full of women, these human computers, several months to create just one table. And that was just for one gun. So they were behind. And Eckert and Mauchly went to the United States Army and said, "We can build a device that will construct one of these tables in hours." Yeah, it was going to be much, much faster. And again, more accurate, we would hope, too.
Can I say something?
Sure.
It's not about normal thing, but
Okay.
Germans had missile shields and the V2 rocket launch, V2 missiles and stuff. It's
Yeah.
never written in history. They don't write anything about that, but it predates American...
No, start again. I heard the V2. Yes, Germans and V2.
missiles.
Yes.
And they had missile shields. They had missile shields. Yeah. I have a documentary on that. I can.
Okay. Okay.
It predates the American. What the research they did.
Okay.
So they had
Yeah.
more technology.
Oh, yeah.
Nothing was written because most of it was destroyed during
Sure.
World War II.
Sure.
They predate everything.
Okay.
Here together.
Right. And as a matter of fact, related to that is in the video you're going to see that many people look at a German invention during World War II by Konrad, right, by Konrad Zuse. And many people look at that as the world's first true computer. The reason I don't is because that device was not general purpose. It was still a spectacular device, don't get me wrong. Yeah, I mean, Konrad Zuse survived after the war, and all the plans are there, whereas the actual device itself, but I mean, we could tell. I mean, and absolutely, he had these ideas, he had them independently, but I think there's a key thing missing. Now, again, other people say, nope, Konrad Zuse, German was first. Okay, and yeah, and I mean, if you want to talk about did the Germans in World War II have sophisticated technology more? Yeah, even more than the Allies? Yeah, absolutely. Okay, yeah, good point. This week, I increased my productivity by improving my morale. I watched funny YouTube videos from morning until dusk. That's all you did? Don't worry, I'm almost halfway done. Okay, sorry. Now, here's the interesting thing to note about the ENIAC story. The ENIAC, the computer, was actually completed after the war. When you stop and think about it, if you create a tool and the problem goes away, then your tool's no good. I mean, you just throw the tool away. Why? I don't need it anymore. But ENIAC was a different kind of tool. The ENIAC was still useful. The instructions were changed. Here's where we had the hydrogen bomb discussion earlier. So although the ENIAC couldn't help creating the ballistic trajectory tables, it was too late, they reprogrammed it. They changed the instructions, and it solved a different problem. The ENIAC then was general purpose, and I would say this is why it gets the title First True Computer versus some other things that people claim, is because this idea that it was general purpose.
Could be reprogrammed.
Exactly, it could be reprogrammed. Reprogrammed with a different algorithm, absolutely. The original idea was it needs to solve this problem of ballistic trajectory tables. But when that problem went away, we said, that's fine, we don't have to get rid of it. We'll change the algorithms, the instructions, we'll reprogram it. It will still be useful. Yep, good point. Now, there's another thing I want you to consider. The founders of information technology, both the people we talked about with the 4 different threads, and then the folks who created the first true computer here, these people were what I call liberal arts people. And this is what I mean by that. Concordia University, Wisconsin is a liberal arts university. If you were an undergraduate here, as I mentioned at the beginning of today, we would require you to take many different subjects outside of your major. And even as a graduate student, although you only take courses in your major, you've noticed how, at least in IT, and this applies everywhere, we've talked about things that some people would say, that's not directly IT, like worldviews and some other things. That's all part of having a liberal arts foundation. The liberal arts means you have a broad base of knowledge. Sometimes people say, well, that's not important. I want to be an IT professional. I only want to take IT courses. And here's my response. Do you think the people who created information technology, did they have degrees in information technology? No, they didn't. There's no such thing. They created it. What did they have a degree in? And the answer is, regardless of what their degree in, they had a broad base of knowledge. All those people I told you about, remember Shikard, lots of different things, same with Pascal, same with Eckert and Mockley. None of these people are your stereotypical geek or nerd. They're not just people that talk in ones and zeros to a device all day long. They're people that were well-versed in many different areas. Yes. They not only, it's not that they were necessarily geniuses, but they did know about a lot of different things. Okay? This is a good model for us in IT. If you say, all I want to do is just tell me ones and zeros and I'll just program in JavaScript for the rest of my life. No, sorry. Even if that was your job function, knowing about other things is going to make you a better JavaScript programmer. Liberal arts, it's a good thing. You're at a liberal arts school, so you're going to get it anyway. Might as well celebrate it, right? A lot of people talk about various computer generations. I'm just going to start because I just want to point out something at the very beginning here. But if you ever hear the term computer generation, a computer generation is really based upon the actual hardware that's used in the processor unit. So if you opened up a historic machine, if you opened up the processor unit and looked inside to see what it's made of, that would tell you the generation that it corresponded to. For example, okay, yeah, you know, we are talking about ancient history. I know that. For some folks, something that happened 10 years ago is ancient history. If you can't see it, there's a desktop and a laptop, and looking at an old mainframe, it says dinosaur exhibit. Yes, so from millions of years ago, or at least it seems that way. But again, this is our origin, this is our heritage, so it is important, and you can glean some insights that will even help you in the present. All right. The first generation of computers, do I have a year? I don't want to do that. No, good. I didn't want to write years or anything like that because I didn't want you to worry about it. But what identifies a first generation computer is vacuum tubes. Come on, vacuum tubes. Thank you. If you opened up the ENIAC or any other first-generation computer, inside you'd find a vacuum tube or many vacuum tubes. Did I mention the ENIAC had 18,000 vacuum tubes? That's a lot. These vacuum tubes are about the size of a light bulb. Now you're wondering, what is a vacuum tube, right? What's a vacuum tube? I'm going to tell you. A vacuum tube is a switch. Now, if you're actually a vacuum tube engineer or electrical engineer, you'd say, well, technically a vacuum tube is an amplifier. Yeah, but we're going to use it as a switch. And by that I mean just like a switch on the wall. A vacuum tube is on or it's off. It allows the passage of current or it blocks it.
So the first generation computer, the switch?
Yes. Let me step ahead a little bit. All computers work via switches, even computers today. But first generation computers, the switch was vacuum tubes. Yeah. Second generation, something different. Third, something different. Fourth, something different. Yep. Right. So it's just like on, off, right? Now, what's that have to do with the history? Well, these switches are used to form gates. We saw that earlier, right? These gates do Boolean operations. And this was a tremendous insight that was made in the 20th century when a group of individuals said, hey, wait a minute. This work of George Boole, this logic, we could use that. Not only could computers control functionality, but they could actually do processing based upon logic gates and circuitry. So the original vacuum tubes on-off then were used to do true-false or the George Boole stuff. Good. Oh, this is so deep. It's not even funny. Thomas Edison, you remember him, light bulb, on-off guy? Most people have an in and an out box on their desk, but Tom had an on and an off. Oh, I can't even say it. On and off box. Sorry, yes. Let's ignore that one. Now, there's something interesting to keep in mind, and that was what was public perception of computers in the 1940s and the 1950s, the first generation. First of all, realize we didn't call them computers. Computer was a job title. You might have been a computer. Okay. Yes. Actually, we called them giant brains.
So this is the first thing.
Yes. Computers were not called computers. They were called giant brains.
Actually, in English, we call like driver.
Yes.
Person.
Yes.
Computer.
Exactly.
Yeah.
Yeah, exactly. It makes sense. The problem is, today when you hear computer, you think a device, right? But yeah, the word is just a very common sense word in English. It's one who computes. Yeah. Okay. Now, I want you to tuck that away. We called them giant brains. I forgot to bring the book, but I have a book in my library by Edmund C. Berkeley, who was probably a preeminent computer scientist of the day. And in a 1949 book entitled Giant Brains, Edmund Berkeley writes, "A machine can handle information. It can calculate, conclude, and choose. A machine can perform reasonable operations on data. A machine, therefore, can think." That was 1949. Do computers think? Most computer scientists would say no, at least not today. Yeah, and we're going to talk about artificial intelligence, and we're going to do that in the fourth unit.
They are laws that
Okay.
God.
Pardon me?
They are artificial intelligence laws, right? Classified laws that God. So you can't give a computer. You can't write an AI hybrid.
Let's talk about that. I don't want to get off, because we will cover that.
They can,
Yeah,
none
we
of
will.
it's covered.
Okay. Well, we'll talk about it. Good. Do computers think? Not today. But we will talk about what is this in the future, and maybe even the very near future. So tuck this away. So we're talking about the era of the 1950s. That's a long, long time ago, right? 65 years ago. And couple that with something else that happened, at least in the United States. In 1952, there was a presidential election. You don't have to remember, the two candidates were Adlai Stevenson and Dwight David Eisenhower. But something happened on this November evening in 1952. A giant brain, the UNIVAC 1, predicted who would win the election. And it was right. Okay? Yeah. Well, yeah, actually, and it did it in such a way that even the folks who initially looked at the prediction said, it's wrong. It's wrong. Okay. Very interesting story. And you put those two things together, it's supposed to be kind of funny. Where's my sound? Okay, that didn't help. It sounds really funny, right? Oh man, giant brains could predict the future. Those people 65 years ago, that was funny stuff. I want you to be careful. I call this a giant brainer. And this is what I want to point out. Do you think people 65 years from now will look back at 2015 and say, that was pretty funny? Oh, absolutely. Absolutely. Every generation believes that this is the pinnacle of technological development and nothing will be better. Things change, right? So, yes, rapidly. So we have to be careful.
Tablets and stuff, how does Star Wars?
Yeah, absolutely. See, with you put yourself both forward and backward. There's every once in a while I run across something I say, this is so clever, I wish I would have done this. So you see the guy in the astronaut suit, future man, goes to the past here, okay? So all these guys, looks like 1960, right? So you're saying people will tweet what they're eating for breakfast and upload pictures of their breakfast to a Facebook? And other people will look at the breakfast and make comments? No offense, future man, but is everyone in your time retarded? Sorry to burst your bubbles, dudes, but you asked, yes, that's the future. It does sound a little ridiculous, doesn't it?
Saying like 15 years ago, it said the government would see us, it would monitor us. Well, what's happening?
Yeah, exactly.
The future.
Exactly. Yeah. All right. We're going to watch a video. And for those of you at a distance, if one of the links is broken, be sure and let me know. Before we see that, let me give you a little background. This is part of a series produced by one of the professional societies in IT. It's called the ACM, Association for Computing Machinery. Now, it was produced in the 1990s. So any current tech is well out of date, right? It's 20 years old, to be sure. But the first episode in this series was entitled Giant Brains. Okay? It's part of the series was The Machine That Changed the World, and the first one is called Giant Brains. And this is all about the historic development of IT and computers. We've talked about some, but others we didn't get to see. So although when they show you current stuff like an Apple II, you'll say, and a floppy disk, and you'll say, don't let that throw you off. It's going to give you some of these insights. Some I tried to give you some background for, as such that you can understand really what's happening there. Okay?